All right, so when we're talking t-tests and SPSS, and in general, there's different kinds of t-tests for different kinds of data that result from different sorts of data collection strategies. So this quiz is a little bit unique in that there's 3 different data sets that reflects the realities of the 3 different datas that work for the different t-tests. So I'm going to go ahead and share my screen. Thing. Okay, so like I said, there's the 3 different data sets. They're labeled in Canvas as like data set lab quiz 6, 1, 2, and 3. And I think they're labeled by the kind of t-test they apply to. Yeah, so for this first one, where it's your independent samples t-test, it's labeled thusly, so it's easy to figure out which one is which. So first up, we're going to be doing our independent samples t-test, which is when you have participants who are in completely separate groups or conditions. Your participants will only ever see one of those conditions. So the groups are completely different and independent of one another. So for this first prompt, say you're interested in whether nostalgia impacts mood, you randomly assign participants to contemplate either a nostalgic memory or an ordinary memory. Afterwards, they rate their level of positive affect. You collect data from 20 participants. So your data set looks like this, right? You've got your 10 participants in the nostalgia condition. These numbers represent their affect score. Likewise, over here, a completely separate group of 10 participants who got the ordinary memory condition. So then the data set looks like this. A couple things that I'll note in terms of this being the independent samples t-test data set is I have 3 different variables created here. One for participant ID. This is just where I number participants, 1 through 20, however many I have, so that every participant has a unique numerical identifier. Condition. So this is important in doing an independent samples t-test is the idea that there's a grouping variable that's like your independent variable. So this is a separate variable in SPSS that has its categorical labeling associated with it. Okay, so all of the participants who are in the nostalgia group, there's a 1 listed for them in the condition variable indicating that they received the nostalgia prompt. The reason it's valuable to create these labels in SPSS is because this will use those actual written labels in our output, so it's a little bit easier to interpret than having to go back and be like, what was group 1 and what was group 2? But you need to have this separate grouping variable in order to run your t-test. Then affect, that's your dependent variable. So when you then look at the actual data view, right, you've got participants 1 through 20. The first half were in the nostalgia condition, denoted by that 1. The second half were in the ordinary memory condition. Then this over here represents their actual affect score, which was the dependent measure. So conduct an independent samples t-test. Why in this case would we choose to perform an independent samples t-test? Right? It's because the nostalgia group and the ordinary memory group were completely different. Participants only saw one of those conditions. So here's how you actually run your independent samples t-test. You'll compare means, independent samples, your grouping variable, that's your IV, so that condition. You need to click define groups, and you just need to list group 1 and group 2. You could flip these around and call group 1 the nostalgia group, group 2. It will not change the interpretation at all. It would flip the sign of your t-statistic, but that does not change the interpretation of it. If you got a chance to look at the t-test lecture materials, basically whichever group is coded as 1 is the first value in the numerator that you subtract the mean of the second group from, and if you flip it around, your actual t-statistic will remain unchanged. It'll just be flipped in value. So it doesn't really matter which one you call 1 and which one you call 2. That designation is arbitrary. It's a categorical variable. You do need to select that. Then test variable, that is where your DV should go. You shouldn't need to select any other options. At that point, you can hit OK and run your independent samples So then you're going to want to find the mean and variance for the nostalgia group and the ordinary memory group. So those values you can find up here in the group statistics box. Since the t-test is about mean differences, right? Does the nostalgia group have a higher average affect score than the ordinary memory group? It's all about comparing means. So you do want to know which mean is what. So the mean affect score for the nostalgia participants, 5.72, and it was 5.2 for the ordinary memory condition participants. Now, in just eyeballing means, you would say, yes, the nostalgia group had a higher positive affect. The t-test is about evaluating that difference for significance. So that's what we're going to look at the bottom. On this point about the variance, so the variance isn't listed here, but you do have your standard deviation, but it is variance that is used in the t-test equation. So it's valuable at this point to remember that you get the variance quite easily by just squaring the standard deviation. Right, standard deviation is notated as S and variance is S squared, because variance is just that value you get before you take that final square root of your standard deviation. So to get the variance for the nostalgia group, you would just take the standard deviation here and square it. And for the variance for the ordinary memory group, you take that standard deviation and square it. All right, so then what is the t-statistic and the p-value? What does this tell you about the impact of nostalgia on affect? This is where you go down here to the independent samples t-test and you find the t-value. That's this value here. So your obtained t-statistic is 0.971. The p-value, which is here in this sig two-tailed column, is 0.345. That is larger than 0.05, meaning that this difference is not significant, right? These means are a little bit different, but it does not rise to the level of significance. So we couldn't conclusively declare that nostalgia boosted positive affect because the difference was too slight that it may be the result of just a fluke. That p-value is pretty high, and it is definitely not significant. So interpret this t-test based on its non-significance and tell me what this tells you about the relationship of nostalgia and affect or lack thereof. So then Levene's P and F. So the Levene's test is a sort of an add-on analysis for your t-test that evaluates the assumption of the t-test of what we call homogeneity of variance. This is an assumption that should be met when you run your independent samples t-test, and this is basically that the variance of each of the groups is roughly equivalent. It doesn't need to be exactly the same, but it needs to be roughly equivalent. If the scores in one group were vastly more spread out or variable than the other group, it sort of diminishes the strength of your t-test. It makes it harder to interpret. So the Levene's test actually evaluates for homogeneity of variance. So you'll notice here, this F value of 0.466, that's your Levene's test F value. And then your significance here for the Levene's test is 0.503. So this over here, this 0.345, that's the p-value for your t-test. This is the p-value for your Levene's test. So this is actually good. The Levene's test, if it was significant, would tell us that the homogeneity of variance was significantly different. And you don't want that. So you like for this F statistic to be small, and you like for it to be non-significant, because if it was significant, there's something problematic with our data set. If it was to be significant, the easy fix is to just use these equal variances not assumed values in interpreting your t-test, which in this case are the same. Sometimes it's a little bit different. The t-statistic is a little bit lower, but since we have cleared the assumption for homogeneity of variance, that's a good thing. We have met that assumption that we wanted to meet. Okay, so then lastly, in this case, would you opt for a one-tailed test or a two-tailed test, and why? This comes down to, was there a directional or non-directional prediction? So up here it says, say you're interested in whether nostalgia impacts mood. It doesn't say nostalgia boosts mood. It doesn't say nostalgia diminishes mood. It just says impacts. So that's non-directional language. Use that to set up your justification for one-tailed versus two-tailed based on what you know about directional versus non-directional hypotheses. Okay, so that's it for your independent samples t-test. Any questions so far? All right, so let's move on to the next t-test. Make sure to just keep your output window open, and then it'll have all of your t-tests in the same file, even though we're using different data sets. SPSS will just keep one single output window going as long as you keep it open. All right, so suppose we want to test the effectiveness of a program designed to increase scores on the quant section for the GRE. We test the program on a group of 8 students. Prior to entering the program, each student takes a practice quant GRE. After completing the program, students take another. So this is what we called a repeated measures design. What that means is that each participant is providing you a before score and an after score. That lends itself to what we call a related samples t-test. These scores here and these scores here are not independent of one another. This before and after score is unique to this first student, and so these scores need to be paired together. So this is quite a different kind of data from the independent samples t-test, and there's a completely different t-test that you would do to evaluate whether or not there was a significant difference in scores after the program versus before. So these are related samples because it's one participant yielding 2 scores. So let's head to our repeated measures t-test data set. It's this one. It's called 2 repeated measures t-test. And again, this data set looks a little bit different. We've got our 8 participants, but in this case, we've got different variables for your before scores and your after scores, because this is what lets you have those before scores paired with that student's corresponding after the program scores. So even though this is still the program variable, it's split into 2 so that in the data set, each participant's scores are paired together appropriately. You cannot jumble up or rearrange these scores because these scores are unique to this participant. All right, so let's conduct a t-test for related samples. In this case, why we choose to perform a related samples t-test, and that's because each participant is giving us a before and after score. It's a repeated measures design, so those samples are not independent, so you need to use a related samples t-test. Okay, so in this case, we still go to compare means, paired samples t-test. You're just gonna pop before and after. As with the previous independent samples t-test, the order in which you put before versus after is arbitrary. Switching these and putting after here and before here, it's gonna flip the sign of your t-statistic, but that doesn't change your interpretation of it. It's a bit arbitrary which one you choose here. When you evaluate your t-statistic for significance, you would use the absolute value to determine whether it is significant. So the sign of the t-test just tells you which score was coded as the first group versus the second group. Shouldn't need to do anything else. Okay. All right, so what is the t-statistic and the p-value? What does this tell you about the impact of the program on test performance? You still have your means up here. It's just that the means are for your participant scores before the practice program and after. Again, you can eyeball the means and say people did better after the program, but was that difference big enough to rise to the level of significance? So for that, you need to go down to this paired samples t-test output. And the t-statistic is this value here under the t column, negative 2.714. As I mentioned, the sign of a t-statistic is not particularly informative. It's just that I put this variable before this one, and this indicates that scores were higher after. But if I had put after here and subtracted the before scores from it, it would have been this same t-statistic. It just would have been positive in value. So you can disregard the sign of the t-statistic when interpreting for significance. So your t-value for this t-test is negative 2.714 with a significance value listed over here of 0.03. So that's lower than p equals 0.05, indicating that we have a significant t-test. What that tells you in the context of your repeated measures design is that scores were significantly better after the training program. Once again, justify for, in this case, would you opt for a one-tailed test or a two-tailed test, and why? We wanted to test the effectiveness of a program designed to increase scores. So think about the directionality of that language and whether or not it lends itself to a one-tailed or a two-tailed test. Okay. You guys still good? Ready to go on to the third one? Keep stopping the screen share just to see if anyone else has been in the waiting room, but it appears not. All right, so then our last one. Suppose we want to assess whether husbands or wives have higher levels of spousal satisfaction. We assess this by recruiting 10 married couples to participate in the study. Both husband and wife rate their level of relationship satisfaction. So again, this is a slightly different kind of data. It's still a related samples t-test, but it's not that every individual participant is giving you 2 scores. It's that each spousal pair is giving you 2 scores. So for each couple, there is a wife and husband pairing, and what we want to do is evaluate within couples, does the wife or husband have a higher level of satisfaction? So again, the data looks similar to what the repeated measures t-test looks like, but it's a slightly different approach for your research method, right? You do still need to keep these pairs of scores together because this couple 3 has a wife and a husband that goes into this pairing, and you cannot disassociate that pair. Those scores belong together because those samples are related. So conduct a t-test for related samples on the data. Why in this case would we choose to perform a related samples t-test? Again, a related samples t-test is appropriate either when you have a repeated measures design or related samples like this. So a spousal study, a twin study, that would indicate that there's not participants who each individually are giving you multiple scores, but that each couple or each twin pair is giving you multiple scores. All right, so conduct our t-test. Again, the order in which you put wife versus husband doesn't matter. You could flip it. This is just coding the wife in the pair as variable 1 versus husband as variable 2. If you switched the order, nothing meaningful would change about your t-statistic. The sign of the t-value would change, but that's not particularly informative. All right, so then we have our output for our final t-test. Again, you have our means up here. So the wife pair tends to have lower satisfaction than the husband in the pairing. Looks like a pretty large difference, but you do want to evaluate for significance. To do that, you go down to your paired samples t-test, and again, your t-statistic is here in the column labeled t, far over to the right. So negative 2.63. If you got 2.63, it's just because within the pair you listed husband as 1 and wife as 2. Completely arbitrary. In terms of evaluating the t-test for significance, it is the absolute value. that you would use to determine significance. And then we have our p-value here in the sig two-tailed column. So our p-value is 0.027, again, lower than p equals 0.05. So that means there is a significant difference in satisfaction between wife and husband within spousal pairs. Whenever you're interpreting your t-test, once you evaluate whether it's significant or not, you do want to go back to the means themselves and articulate what a significant t-test tells you, right? So we know that the difference between husbands and wives are significant. You go back to the means themselves and you say that difference is because husbands are more satisfied. So you want to interpret your significant t-test by going back to the means themselves and saying, oh, one is higher than the other, which one is it? Okay, would you opt for a one-tailed or two-tailed test? Suppose we want to assess whether husbands or wives have higher level of spousal satisfaction, not necessarily predicting that husbands or wives will be higher, just asking whether there's a difference. So that's non-directional language, so use that to justify your one-tailed versus two-tailed test. And then here, play around with this, reversing the order of the entry of your variables. So whatever order you input your variables in, reverse it. Do the same analysis and what happens to your t-values. Let's try that out just for shits and giggles. Okay, so our t-statistic is negative 2.63. I put wife first, my wife. Put wife first last time, so let's put husband first this time. This, if you were to look at the t-test computation equation, right, the numerator of the t-statistic is about just computing the difference between means. So when filling out the formula to calculate my obtained t-statistic, this is just as simple as the wife mean first versus second. That's what that difference would yield in terms of computation. So then, as I mentioned, the sign of the t-statistic is not particularly meaningful because when I flip the order that I code my variables, right, this t-statistic is the same absolute value. It's just that the sign has flipped because I just recoded my categorical variables essentially. So everything else about the t-test is exactly the same because the order in which you categorize that categorical variable is ultimately arbitrary and does not change the interpretation of your t-statistic. Again, the t is significant. The means are the same because the data itself doesn't change. It's just that now the husband scores are first in the equation and the wife scores are subtracted from that, meaning that the numerator in your t equation would be positive, meaning that the t-statistic is positive. Interpretation does not change whatsoever. The order in which you input the variables in your paired t-statistic or in your independent sample statistic, it's arbitrary. You'll notice that the sign will flip, but nothing about your interpretation will change. So that's basically it for running all of your t-tests in SPSS. I'm going to hang around and answer any questions if you have them about the lab quiz or anything else, but that basically does it for my instruction on the t-test lab quiz.